thank you all, and I would like to thank the previous presenters because they set kind of the basis to discuss about greening the seas. So in my presentation, what I would like just to convey to you is quite a broader message around the story around decarbonization. It's kind of connecting all what we have heard about so far, but also integrating information about the challenging landscape that most probably you are already experiencing. And you have quite questions on it, like for example about the EU ETS or Fuel EU, or how that kind of regulation could impact your daily operations in the end. So starting with this challenging landscape, of course the IMO greenhouse gas strategy is now quite known. It started getting a zero emissions by 2050. This is very strict. This is something really hard to achieve unless there are drastic changes in the ways that ships are designed and operated. Meaning that if we focus on Fuel EU and all the regulations under the European Green Deal, it's about changing the fuel, changing the way that systems are being fueled, not only maritime systems. About IMO, there is this strategy to reduce emissions, and it's kind of constantly focusing on a per year reduction, either through CII or through other regulations that tend to gather data, use new technologies, of course, and create more requirements for reporting, and of course creating more jobs around the whole operations. So all these regulations come with a multilateral impact in different ways. Either the way that ships will be designed in the future, new technologies like carbon capture that we just heard about, and we will speak thereafter about more technologies and how decarbonization can grow. Until now, not until now, maybe until some years ago, fuel was just some problem, let's say, of the cargo owner. So the only problem around the fuel was its cost, and its cost was taken by the owners of the cargo. But now, all these new regulations are including carbon risk into the risks of operations of the vessels, of the design of the vessel, and whether it's going to be financially attractive for the charterers. So all this regulatory context is creating a new setup for ship management and operation, ownership, management and operation. Greenhouse gas emissions have a cost. Greenhouse gas performance is accountable, and there is a range of metrics that have to be reported, met, verified, subject to verifiable data, etc. So it's kind of a complex environment that, yes, it creates a lot of challenges for the future, a lot of potential for new technologies uptake, but also a potential for new jobs. And we have to face that. Let's have a look on decarbonization solutions and what can be of relevance. Of course, ambitions create the need to plan, and to plan fast, to collaborate, start linking to associations, to alliances, to collaborations, in order to find the right solution for the right partnership. There is no holy grail here. So there are many different ways to achieve the goals, but that demands cooperation. So this is why DNV has this catchy phrase that collaboration is the fuel for the future. The types of technologies that, for example, somebody could lean to is related to either technical or operational measures. Like, for example, you just heard about carbon capture. That's quite innovative. And it could be really become a solution for retrofit in the future in order to achieve drastic solutions in the emissions. But however, carbon capture does not come without an energy penalty. and does not come without the need to have infrastructure for disposal of the CO2 at ports. So nothing is ready. This is the time to plan and collaborate. Now, about reducing the energy losses, if we delve into the technicalities, this is about reducing either the energy demand, so improving the operations, either improve the power production, the energy converters, and that is something that the technology providers of marine engines have been looking for years, or to change the fuels, and also to include new types of energy sources on board the ship. That's very known. You might have heard about WASP, which is wind-assisted propulsion. You might have heard about solar panels on board the vessels. Not everything is applicable everywhere, and that is something to consider when planning for decarbonization. We heard about hydrogen before, and yes, hydrogen could be a solution for some small scale shipping segments. Always there are barriers to overcome, like for example costs and the return of investment of each decarbonization solution. That being, for example, biofuels, which come with a substantial difference compared to current fuels. However, they might be subsidized partially, as what is happening now in Rotterdam. And not to mention, for example, the availability of space on board, which is so important. Like, for example, about carbon capture and scrubbers, where to put it if we tend to target a 70% recovery of CO2. If, for example, we are using liquid amine as a technology. So there are always barriers, but if there is proper planning, the right solutions can emerge. I wouldn't like to consume the time, but just to give you a little bit of a taste around some very important technologies, like wind-assisted propulsion. Are we going back to sails and onboard ships? Not necessarily, but why not exploiting that potential in particular routes where it can be proven through CFD analysis and through real operation data that there is potential to improve. How much that can be? Could be up to 11% or even more. And this is attractive, but it's not always for all routes. And therefore, this study has to be undertaken. Alternative fuels. We spoke about hydrogen. What about ammonia or biofuels? It depends. Always when we talk about fuels, the most important factor is cost and availability. So where to find it, how much does it cost, and what is the differential cost compared to other technologies, like carbon capture as an example. On the other hand, and to connect it also with the previous presentations that had to do with the human factor and seafarers on board, what about training of these people to utilize fuels like ammonia, which is not something obvious and associated with quite a few risks? And of course, not to mention safety risks and machinery performance risks that have to do with degradation of the machinery. Therefore, no holy grail. Here we talk about collaboration and finding the right solution that fits the trade. Onboard carbon capture, yes, we heard about that. This is a technology that has been used for years. Since 1960s, it has been used for enhanced oil recovery in the US. So it's not old. It's not new. It's quite old. But if you install it on board the ship, depends on the technology type. If there is capacity to have both the capture technology and the treatment and the storage to dispose CO2 in the port. And then what about liquefying CO2? How much does it cost? I mean, how many kilowatt hours per ton of CO2 would be required? We speak about something that could be equivalent with the use of scrubbers, meaning that if we are talking about the use of scrubbers on board ships, we know that this might need some extra load in the auxiliary generators. Fine. If the cost justify the investment, why not? So, to plan ahead, we need to understand these challenges, to put down all the different solutions, address, first of all, what are our ESG targets as companies? How does these solutions, technical or operational solution, fit to these targets? Then, is it meaningful to create a decarb plan that includes all these different factors, all these different technologies? And then initiate proper collaborations in order to achieve our goals. And with that, I would like to thank you.